Hello everyone, it's Alex again, and today we are going to be doing a KCL and KVL combined problem. And so, as you can see here, we have currents, voltages, and power in this circuit. So let's just get right into it. So the first thing that I would probably do is take all these powers, and if I'm able to, find the respective voltage or current. So in this case right here, we can't find either the voltage or the current because we don't have a voltage or a current here. But here we have 2 amps and the power. So we can use P equals IV, and we know we can get minus 1 volt plus. And the reason why I got that is because right here, this is a positive power, so it's going in through the positive terminal, and we know the direction of our current is going in this way, right? So it has to go in through the positive way. So the next thing that we should do is find the voltage of this guy right here, right? And because that's the most obvious thing that we can do. We can actually go ahead and solve this for this voltage right here as well. But since we're still in this area, might as well do it. So loop 1, loop 2, and you can solve for this voltage with either loop, because you are given the voltages of either one of these, or you calculated the voltage of this one, and you can therefore use it in this calculation right here. So let's go ahead and just do both. So I arbitrarily assigned a loop direction, and loop 1 is counterclockwise. So loop 1 is going to be equal to plus 1 plus 3 plus V equals 0. And we get V equals -4, right? So, and as you can see here, we have a negative power. So that means that the current is going in through the positive way. And in this case, we're going to say that we're going to just assign this as being the right current, okay? So we'll just say that we've got a current going in this way, and we're going to say that this side right here is -4, -4, and then plus. Now here, we're going to go around, also counterclockwise, and I'm just showing you this so that you can prove that it doesn't matter which one you start with. So we have L2, sorry, this would colon, and we get plus 6 minus 10 plus V equals 0, and we get V equals plus 4. And so going in this way, we get this current going that way, right? And this is consistent, because how can we make a negative power if we're going this way? So the actual direction is going this way, because then if we did it this way, we would get a positive 6 watts, which is not correct, right? This is wrong, as given by the problem. So we can delete that, and we can delete that. Okay, so we figured out this guy right here to be -4 volts. Okay, now that we have the voltage right here, and I'm just gonna delete these guys to clean it up. Now that we have the voltage here, we can actually find the magnitude of the current. So let's just go ahead and find the magnitude of the current. Now, we don't need to consider this negative sign anymore because we've already considered it, okay? So no need to consider it twice. So we have P equals IV once again, and I is going to be the power of 6 watts over 4, which is equal to 1.5. Oh, my pen's messing up. 1.5 amps. So we know that the amps are going in this direction, right? Now we can solve for we can solve for all of this stuff right here, because originally we only had 4 volts coming in, and 4 amps coming in, and that's all we had, right? So let's go ahead and do that. So right here we have 2 amps going down, and then 1.5 amps going up that way. So this way must be 0.5 amps, right? So then that means we have 0.5 amps going in this way, and we have 4 amps going this way. So then that means we must have 4.5 amps going up that way. Okay? And we can actually see if all of that is consistent right here, and I'm going to do it in red because I'm going to erase it. We have 2 amps going that way, 4 amps going that way, 4.5 amps going into the node, and 0.5 amps, sorry, not 0.5 amps, that would not be right, 1.5 amps going into the node right here. And as you can see, 1.5 plus 4.5 is 6. 6 amps going in, 6 amps going out. So we can ensure that that node is complete. And for the final portion of this puzzle is the voltage of this guy right here. Okay, so I already drew a loop right here. We can call it loop 3. And loop 3, we are just going to do a simple KVL. We've got -10 plus 3 plus V plus 2 equals 0, and ultimately we get V equals 5 volts. Okay, and that's a positive, and we know for a fact that this current is physically going down this way because it was given to us in the problem. So it will be plus 5 volts minus there. Okay, and that's all for this problem. Well, for solving all of those guys right there. So it's very, very important to make sure that you get your directions correct. And no matter what you assign your own directions, whatever is being given to you in the problem ultimately trumps whatever you want to do with your directions. Yes, you can arbitrarily pick them, but if the problem explicitly gives you a certain way it wants it to be done, then you must do it that way. So the second part of this problem is proving conservation of power. So to make this simple, let's call this component 1, 2, 3, 4, 5, 6, 7, and 8. Okay? So we'll have power 1, power 2, power 3, 4, 5, 6, 7, 8, and we will calculate the powers of each one of these components. Okay, so power of 1. Well, the power of 1 was given to us at the beginning of the problem, so we can just simply put plus 2 watts, right? Then power 2 is going to be plus 4 amps because it's going in through the plus way, times 3 volts equals plus 12 watts. Okay? P3, it's going to be plus, I believe that was 2 amps times 3 volts. Yes. 3 volts equals plus 6 watts. And then 4, now, once again, this one was given to us right here, negative 6 watts. So negative 6 watts. P5, we've got negative 4.5 times amps. I'm just writing out these units so that you remember what they are. Eventually, when you become really good at this, you're not going to need to write all of that stuff. But you do, at the end of every problem, remember to write down your units, okay? Let me make that 5 a little bit better. Okay, negative 45 watts right there. P6, so we have 4 volts going into the positive, 4 amps going into the positive way, plus 4 amps times 5 volts equals plus 20 watts. And then we've got P7, and P7 is plus 0.5 amps times 6 volts equals 3 watts. Right there, almost running out of room. P8, for last but not least, we've got plus 4 amps times 2 volts equals 8 watts, right? Yes, plus 8 watts plus 3 watts. And then, remember what we said, the sum of the individual powers must equal 0 for power conservation. So all you're going to do is say 2 plus 12 plus 6 minus 45 plus 20 plus 3 plus 8. And using a calculator, please use a calculator, because you will make stupid mistakes. I have, and so I'll get back to you right when I get my calculator. And adding it all up, we get 0. So we are good. So this is how you do a problem with everything combined. And yeah.